Hi everyone, welcome to my channel. Today I will start with Inequalities 02. Those who haven't seen the 01 video must please see the video. I will give the link in the description. I will give the link in the description. Today in the previous video we have done AMGM HM inequality and we have done a few questions. 3 questions we have completed. Today I will start with the fourth question. This is the fourth question. Let's start with it. Please pause the video and try this question out. Hope you have tried. I'm moving on to the solution right now. First, let me tell you one thing. Let me go to the black screen. Yeah. See, if in the question, I hope you have seen, there are two ways to solving. First, one simple way, another using AMGM inequality, AMGM HM inequality. Let's start with the simple way. First, let us have let's check this. Up to, let's say, up to, it's continued up to, and so on, up to 10. I'm writing 7, 8, 9. I'm leaving a gap between C. Now, here will come 4, 5, 6. A huge gap is left. No need of that. See these two numbers and these two. If we multiply these and again this, 2 and 9, then 3 and 8, 4 and 7, we will see it will always be less than the multiplication of these two, 5 and 6. This will always be greater than the other multiplications. One can prove it simply, I think. Yeah. If we randomly mean average of all numbers from 1 to 10, it will come to 5.5, I think. Yeah, 5.5. See, 5.5 minus 0.5 and plus 0.5 is now using the formula we have learned, a plus b into a minus b a square minus b square. We will get that way 5.5 whole square minus 0.5 whole square. And again, if we multiply 4 and 7, then we will get 5.5 whole square minus 1.5 whole square, which is simply we can see it's less than 5.5 whole square minus 0.5 whole square. This is the proof we can tell you, and basic proof. And so if there are two n terms, so how can we write the statement? Two n terms, let's say, then we can write any multiplication. Let's say 1 into 2n is greater than n into n plus 1. And similarly, other statements can also be checked, like 2 into 2n minus 1 and so on. If it is 2, then 3, it will so on go, and it will be 2n minus 1 and so on, it will go on. But this term will remain same. This term will remain same. This is the thing I wanted to tell you. With this knowledge, we can easily solve the question. Yeah, this was our question. Let me check. Yeah, let's start. How to approach this question? This 2n factorial is there. We can write it as 1 into 2 into 3. I hope you know the meaning of what is factorial. It's just multiplication of all numbers starting from that number up to 1, or reverse of that, anything, as you can say. This is the meaning of this statement. Now we have to prove this is always less than the RHS. How to approach that? We can do this. simply by saying that 1 into 2n is always less than n into n plus 1, right? As we have saw in our black screen. Now again 2 into 2n minus 1 will come out to be the same, right? 2n minus 1 and less than n into n plus 1. Yeah. Now you can understand it will go on. This statement will go on up to n into n plus 1. Yeah, sometimes this is equals to, but we can write it again as a less than equals to. Anyways, it does not matter what happens. Anything equals to can be represented as anything less than equals to. This is the statement. Now multiplying all the equations we multiply. When we multiply the LHS, see, we simply get a very nice term from 1, 2, 3, 4 up to n. Then again starting from n we get n plus 1, n plus 2, n plus 3 up to 2n. So what is this? This is 2n factorial, as I can say. And what is this part here? The RHS. RHS can be, this is less than, only less than, because other terms are always less than, but here the last term is only less than equals to, so this will be less than symbol, and this, there are n terms here, n terms, so we can get this to be equals to n into n plus 1 whole to the power n. This is our given statement to prove. Another method is there which is a little more descriptive method in terms of MGM inequality, but it's quite tricky. This was I think a simpler process. Now let's see this. 2n factorial is this. Now this can be written as, let's write this again. We can think of the even numbers first. Every even numbers we can take 2 as a 2 as a common. There are 2n numbers, so n even numbers, so we can write this as 2 to the power n into 1 into 2 into 3 into up to the n, means this is the all even numbers product I am taking up to n. Yeah. Now the odd numbers remains. Odd numbers are 1, oh sorry, I'm writing plus. Yeah, this is odd numbers we have to take. Odd numbers 1, then 3, then 5, and so on. 1, then 3, then 5, and up to, it will go on up to 2n minus 1. 2n minus 1. Done. Now let's think this statement. This is a geometric mean of some very complex sort of arithmetic mean. Let's find out what the arithmetic mean is. This will be product of 2 to the power n, then 1, 2, 3 up to n, then again 1, 3, 5, then 2 up to 2n minus 1. Now, then we have to use greater than equals to symbol, then everything is divided by n. But if we directly write this as 2 to the power n, then outside means this by n is not, I'm not including that. Then we can write this as n into n plus 1 whole divided by 2, means 1 plus 2 plus 3 plus 4 up to n. We have added those, and then the n comes here. I wrote, and another term will come this. this 1 3 5 up to dot dot 2 n minus 1. This is always there. Now let's think about what is the product of all odd numbers. We have learned a formula that product of n odd numbers is n square. How many numbers are there? There are n numbers only. See, if this is this is the first number, this is the second number, this is the third number. Means see, every number is following the order of 2n minus 1 only. So this is the nth number. So there are n numbers and we will write the sum as n square and again divided by n. Now this was the thing, but another thing we have missed. In GP there must be an nth root, right? There must be an nth root, but not only nth, 2nth root there must be, but since we are not including those 2n part, we can directly write this. I am not including the 2 part there. I am including only the n part. Many things I have ignored from the AP. AP. I am saying AP. Sorry, it will be n. I have ignored the n denominator with 2 to the power n. I have ignored the square there. This all leads the RHS to be more lesser than the AM. So we are quite justified with our process. Now we can do what we are allowed. Just cancel the things. We get this 2 and this power end. Yeah, I've written a wrong thing. I'm again ignoring another part. Just to get the answer correct, I'm ignoring many parts, which we are allowed if and only if that statement is again lesser than the previous one. Now this to the power n, we are also ignoring 2 to the power n whole to the power n. We are ignoring that statement again. Now this 2 power n, this 2 to the power n will cut this, cancel this thing. Now we just remained the statement which we need to prove, which is n into n plus 1 whole to the power n. This is a better way one can think about, but see, it's a more difficult than the previous one, I guess. But then also, moving on to the next question. This is a next question. This means such that such that it's telling A, B, C be the sides of a triangle. Then BC by B plus C, CA by C plus A, AB by A plus B is equals to S. Prove that it is an equilateral triangle. As we know the semi-perimeter. This is A plus B plus C by 2. A plus B plus C by 2. Now you may try the question by pausing the video. I am moving on to the solution. Hope you have tried it out. Let's multiply both sides by 2 now. And this BC, let's transfer this to the denominator of B plus C. Then we will get a very simple solution. I am solving it here. We can write this as multiplying 2 on both sides and dividing BC to B plus C at the denominator again. We will get this sort of statement. 1 by 2 plus 1 by B plus 1, 2 by 1 by B plus 1 by C, again 2 by 1 by A plus 1 by C. 1 by A and 1 by C. And then that will be 2 by 1 by A and 1 by B. You know, it takes time to write. 1 by A and then 1 by B. And that will be equals to 2S, but I'm not writing 2S right now. I'm writing direct A plus B plus C. Right? This is our statement right now, all in terms of ABC. ABC are the sides of the triangle, which simply means they are all are positive. This is the just a basic condition for every AMGM inequality to hold. Now let's see we can write this as this thing can be written this thing can be written again as 2a plus 2b plus 2c by 2. 2a plus, yeah, see right now. We can write this as, this is the trick of this question. After this, there is a very simple one. A by a plus b by 2 plus b plus c by 2 and plus c plus a by 2 plus c by 2 and then plus c plus a by 2 plus c plus a by 2. Now you can check each of the given term. This is equals to s. Now there is no inequality present, so we have to think about what can be here. See, this and this term, please do check thoroughly. These are always, this is greater, this is am and this is greater than equals to this term. This, check this now, these and the last one there, c plus a by 2. While checking, we will again get the similar sort of argument. This, and now let's check this terms. This is again less than equals to this. Now this is what to check. This is the aim of A and B. This is the aim of A and B. This is the HM of A and B. This is the aim of B and C. This is the HM of B and C. This is the aim of C and A. This is the HM of C and A. This turns us to the conclusion that this is the RHS is always greater than equals to LHS. Now this is here, we have found out to a very nominal point. Now when they are equal, when all terms are equal, if each and every terms are equal, you can check this will change to equality. This will change to equality. For this to be changing to inequality, this condition must hold. Now if A is equal to B is equal to C, A, B, C are the sides of the triangle, this simply means that the triangle is an equilateral triangle. Over with the solution. Now our third question for today and the last one for this video. This is cyclic. Sigma cyclic means A by A plus B, then B by C, B plus C, then C by C plus D, then D by D plus A. This is the meaning of sigma cyclic. And then since A, B, C, D are given, we will take only 4 terms, nothing greater. So this, hope you have tried by pausing the video. I am moving on to a solution. This can be written similar to the previous above one, that A by means I am just expanding the term. A by A plus B, then we will add B by B plus C. This will be a long one, but a simple one again. C by C plus J. There's a trick in between, I will tell you. It's a very weird sort of trick, but it will help you to come through this problem. Now this will prove to be less than equals to A by B plus C, then B by C plus D, means it will go on cyclically. No so-called, we are not going to add every such permutations here. We will just add it cyclically. This is the essence of this sigma cyclic. D by A plus B. Now let's see what we can do. We are adding sigma cyclic. Again, one other cyclic term we are adding just to make the question more difficult, I guess. Sigma B by A plus B. Now it will make the question simpler to both sides. Both sides. Yeah. See, A by A plus B plus B by A plus B by B plus C plus C by B plus C by C plus D plus D by C plus D by D plus A plus A by D plus A. All terms will be equals to 1, which means this LHS will be converted to 1. LHS is equals to, each term will be converted to 1 and LHS will be equals to 4. Now, let's see what will happen to the RHS after the addition. It will become B plus D. It will become B plus D by, it will become a very another difficult term, but it will come out to be a easier one. See, B plus D will happen twice, here and here. B plus D will happen twice. So we can write this as 1 by C plus D plus 1 by A plus B plus 1 by A plus B. A plus B. This is the scenario present now. And again, these two terms, same common will come out as A plus C. A plus C will come out and a similar term will be present there, but not the same thing. It will be 1 by B plus C and then plus C plus 1 by, what is the remaining term? A plus D. Now the question is, I guess, easy. See, now we are applying AM-HM inequality. Applying AM-HM inequality here, these are the two terms of AM. This by 2. This by 2 will be greater than equals to 2 by 1 upon each of the term. 2 will move the 2, imagine the thing I am telling. Move the 2 to the numerator of the RHS. It will become 4 by, and the reciprocal of each of the terms. 1 by C plus D is reciprocal is C plus D, 1 by A plus B is reciprocal is A plus B, which will simply turn out to be, this will be greater than equals to, from AM-HM inequality, AM-HM, HM then, this will be greater than equals to this B plus D, then we will come 4 by A plus B plus C plus D. A plus B plus C plus D. Similar case for the second term of the C, D, no, it's plus sign between them, yeah. Now adding with A plus C, then again 4 by, again this term, 4 by A plus B plus C plus D. This will come out to be equals to 4. You will check. I am telling you how. Plus D. Now This 4 by a plus b plus c plus d take out as common, and a plus b plus c plus d will come in another bracket, and all the a plus b plus c plus d term will cancel, and this will be equals to nothing but 4. This is equals to 4, and LHS equals to 4, RHS is greater than equals to 4, which simply means we have come out to our conclusion. This is the conclusion we have taken from these two. These two have led to this conclusion. Now, this question is also completed, and with the note of thanks, I am ending. I will give the link of the previous video in the description box, and also the link for the PDF of this notes of this video. Thank you.